Ladies and gentlemen, welcome to our first video of Chapter 7, and it's still on trigonometry. We're switching gears a little bit. We're now going to work with inverse trig functions, but really I need you to understand it all the same stuff. It's coming back. It's coming back. The unit circle is so important. I really, truly hope that you did not just throw that out the window after we were done with that assessment. Okay, so let's see what we're doing today. Okay, so first things first, we know what a sine graph looks like, right? We could sketch it, maybe something like this. It starts at the center, goes up to a max, then comes back. All right, sorry, max, rest, min, rest. My bad. All right, for cosine, slightly different. We know that a cosine usually starts at a maximum. So we would go max to rest to min to rest to max, something like that. And then lastly, our tangent graph. Our tangent graph. We know that tangent is point, asymptote, point. Or what we really want to see here is that it goes up and down. All right, we know the general shape of tangent. Now, if we think about the word inverse, right? I mean, don't even think trig right now. Think addition. What's the inverse of addition? Well, it's subtraction. Multiplication, division. Square and square root. Anyone know another? How about exponential logarithmic? Ooh, that's a good one too. What we know is that inverse means to undo, or some people like to say go backwards. Go backwards. All right? So really what I need you guys to think about is go back to chapter 6. Think about what we were doing. I would give you an angle. Right? I'm going to come up here. I would give you an angle. And then I would say find the sine of it. And your answer would be a ratio. Correct? Yes? This is chapter 6 thinking. Now what we're saying here, guys, what we're going to get into for Chapter 7 thinking is I'm going to give you the ratio. I'm going to give you the ratio. You're going to have to take maybe the inverse sign, and we show that with a -1. We'll see that in a second, of that ratio, and you're going to get back the angle. Okay, so this is what we know already. This is what we're learning. All right? But these things go hand in hand with each other. This is the same thing as this. It's just written differently. And it depends on what you're given. If I give you an angle, well, then you take the sine to get the ratio. If I give you a ratio, you take the inverse sign to get the angle. So we know that when we use inverse, the angle is the answer. Okay? Okay. Now, moving on. We need domains, all right? We know, especially with trig functions, these things go on forever and ever and ever and ever and ever. And we want to kind of be very specific where we give answers. We want answers to either be negative or positive, which means there's only going to be a couple of quadrants that we use here. For example, if I gave you, let's see here, let's set a quadrant up. Let's say I gave you the ratio 1/2, and I said to take the sine of 1/2. Well, if I asked you to take, the inverse sine of 1/2, right? And we want to find the angle that goes with 1/2. Well, the problem is that can be up here in quadrant 1 or up here in quadrant 2. And what we're going to do is we're just going to chop off quadrants 2 and 3. And we're going to say that when we're trying to find the inverse sine, we only want our answer in quadrant 1 or quadrant 4, because I don't want to get two different answers, right? Again, for this one, if I'm talking about the inverse sine of 1/2, I have two options here. And actually, if I use my coterminals, I have infinite options. So we're just going to always pick 1 and 4 for sine. Same thing kind of works with cosine. It's a little different, though. All right, let's use 1/2 again. If I use the inverse cosine, oh, inverse cosine of 1/2, well, let's think about this. Inverse cosine means that the ratio is 1/2, which means I'd be either up here in quadrant 1 or down here in quadrant 4. So again, two options. I don't want two options. That's kind of ambiguous. I don't know what my answer is. Okay? So what we're going to do is we're going to take one that's positive, one section that's positive, and then one that's negative. All right? Because if this were negative, we would be over here. That means that, again, I want to just make this as easy as possible. I'm going to get rid of quadrants 3 and 4 this time, okay? And I know that cosine, when I use inverse cosine, my answer should always be in one of the first two quadrants. All right, and again, why is it 1 and 2? To allow for positive values and negative values. All right, last one, tangent. Tangent's a little bit goofy. I'll have a little bit more to explain, but again, let's pick, okay, I'm going to change this number a little bit to make it a little nicer. I'm just going to say tan inverse of 1, all right? The inverse tangent of 1. That means it's positive. Well, positive tangents we know occur in quadrants 1 and 3, all right? Negative tangents occur in quadrants 2 and 4. So once again, to be less ambiguous, we're going to set and just always choose quadrants 4 and quadrants 1 because of our graph right here. You see how this is quadrant 4 and quadrant 1? So what we're going to do is, once again, just like sine, we're only going to use quadrants 1 and 4 when answering inverse tangent problems. Okay? So that means if you get some answer that's like 5 pi over 3, well, what's the problem with 5 pi over 3? 5 pi over 3, which is in quadrant 4, actually, you know what? Hold on. Let's talk about something else real quick. Okay, so before we get to that point, I want to say, here's my 0, and I either want to go up from 0 or down from 0, okay? So I know that if I go up to the end of quadrant 1, this is pi over 2, and down here is negative pi over 2, all right? So that means that my domain, my answer, will always have to be between negative pi over 2 and pi over 2 for sine, all right? Well, what happens with cosine? Well, cosine, I start at 0, and I go all the way around to pi. So now I know that my domain for cosine has to be between 0 and pi. Any answer that I have, any angle I should say, needs to be between 0 and pi. Lastly, for tangent, and this is again, alright, so 0 goes up or down to either pi over 2 or negative pi over 2. So once again, same as sine, negative pi over 2 to pi over 2. Alright, now this is actually where I was getting at. I realized I was a little out of order here. Now that we see these domains, I need you to understand that any answer you get needs to be between these angles, or these angles, or these angles. I can't have 5 pi over 3. 5 pi over 3 is not between, or not in, any of these domains. Okay? Okay. Alright, let's get to work solving these. Alright, let's get to work. Alright, so we have a bunch of these to try out. Hopefully they won't be too bad. Again, what we're now thinking is, you have to remember, I'm giving you the ratio. I'm giving you the ratio. I'll even say value. Find the angle. Alright, so let's think about this. We know that sine goes with the y values. So this is me telling you that the sine of some angle is equal to 1. Well, where is the sine equal to 1? If I drew a little sketch, I'm right here, right? I'm straight up. So I know that that angle is what? Straight up. Pi over 2. Okay. Oh, here's something goofy. Arc sine. Interesting. Okay, this is just another way of saying inverse sine. You can always just rewrite it. if you'd like. Or you can leave it as arcsine, it doesn't matter if you're okay and comfortable with that. But I want you to know these two things are the same. Alright, they're the same. So when we move on, I want the inverse sine of 1/2. Well, again, I need to think about, on my unit circle, where is the sine 1/2, or where is the y value half? And that is either here or here, but remember that because I'm working with sine, I only want either quadrants 1 or 4. So over here, up 1/2, that would be a pi over 6, right? Pi over 6? Pi over 6. And again, why is that? Because y is 1/2 when x is √3/2, which means I'm using my pi over 6 or 30-degree angles. Alright? As I move on, again, I can make a little sketch. I want to know when the x value is 0, right? Because its cosine the cosine of some angle has to be 0. And that means because I need to be in quadrants 1 or 2 for cosine, inverse cosine, excuse me, that would have to be up here, right at pi over 2. Okay, and again, why is that? Because this is where my x value is 0. That is the only place where my x value is 0. Alright, as we move on to the next set, let's see here. Inverse cosine negative √2/2. Okay, so negative √2/2. Let's think about this. Oh, well, that would be over here. How did I know that? Well, because for cosine I have to be in quadrants 1 or 2, and because it was negative, I have to be in quadrant 2. That means, well, what type of angle is that? Oh, that's a pi over 4, and in quadrant 2, that means this should be 3 pi over 4. So again, little sketches hopefully will help you guys figure these out. As I move along, sine inverse, I know that my sine or y value needs to be √3/2. So that's straight up here. Not straight up, but up there. And hopefully we remember from our unit circle, or if you need to really draw one and practice it again, that's fine. But this is a pi over 3. Pi over 3. As we take a look at the next one, we have arc cosine or inverse cosine, and I know that my ratio, or in this case because it's cosine, my x value must be negative √3/2. So that means I would have to be somewhere like this. And again, why? I know that my x value has to be negative √3/2, and I know I have to be in quadrants 1 or 2 for inverse cosine. So right here in quadrant 2. Now, √3/2, those are my pi over 6s. How many pi over 6s do I have to be if I'm in quadrant 2? 5 pi over 6. Alright. Perfect, perfect. Here we go. Let's keep going. Tangent of 1. Oh, I like when the ratio is 1. That means what? That the x and the y are the same? And hopefully we remember then that we are at a pi over 4, right? Because that's √2/2, √2/2. Perfect. So this one's nice and easy. Tangents, however, can get a little tricky. Tangents can definitely... Oh, I just realized I'm completely off the page. Great. Here we go again. Tangents can get a little tricky. Hopefully you guys were okay with these pictures. Tangents can get a little tricky. Why? Because it's not just an x or a y value, right? It's a ratio of the two. So we need to think about this. The easiest way to do this is to first create that ratio by putting it over 1, and then remembering that tangent is always y over x. Okay, so here's my y, here's my x. Oh shoot. I don't know where on my unit circle I have a y value of negative √3 and an x of 1. I'm going to write that out. So 1 comma negative √3. Yeah, no, I don't know how to do this. But you know, it does look a lot like 1/2 and negative √3/2. This is what I need you guys to understand about using tangents. A lot of the times, Remember when we were just cancel the 2's out, like cancel the half or the denominators out? Well, now we're putting them back in. All right, so you can absolutely do something like this when you have inverse tangent, if it helps you, but you have to do it to both, right? You got to do it to top and bottom. So now this is a little better. Now I know that when I sketch a picture here, I'm down here in quadrant 4, and that should be, let's see here, that's a pi over 3, 5 pi over 3, right? Okay, 5 pi over 3? No! Absolutely not. That is not okay. Why is that not okay? Let's go back up for a second. We learned that tangent must be between negative pi over 2 and pi over 2. All right, it goes down from 0 or it goes up from 0. So while this 5 pi over 3, you're in the exact right spot. Like, don't think that you're wrong about that. You have to remember that we're not going around. That's not what we're looking for. We're looking for this. This is what we want. So it's still a pi over 3, but now we just say negative pi over 3. Okay? Okay. As we move on, we have another tangent. This one is again going to be a little goofy, so we have a y over x. Root 3 over 3. So if I do the same thing, I'd have 3 root 3 divide by 2. Uh-oh, I don't have a 3 over 2 either. Okay. So this is even trickier. We need to remember that root 3 over 3 is only an option because the denominator was rationalized. We can rewrite this in its unrationalized form as 1 over root 3. And now we should be good to go. Because when we go y over x, it's going to be root 3 over 2 and 1 over 2. And now I can go through with this picture. All right, root 3 over 2, up 1/2, we're here. That one's nice. This one is pi over 6. All right, we're going to skip the last 3 for right now just because I'm taking forever, as normal, as usual, and we are going to move on to our next page. So I hopefully get through this. All right. Okay, so up at the top, we're now going to kind of work on two-step problems. And what I want you to do and understand is you got to work from inside out. All right? That means that I need to take care of this inside part before I can take the inverse sine. So I'm going to start by rewriting inverse sine, but now I'm going to replace sine pi over 6 with its actual value. Well, pi over 6, where are we at? We're over here. And we know that the y value, because it's sine, the y value is going to be 1/2. So I know that I want to take the inverse sine of 1/2. And now I'm at the same place. What's the angle when y is 1/2? That's pi over 6. That's pi over 6. What happens on this next one? All right, what happens on this next one? Well, again, I'm going to take the inverse sine, but now I need to take the sine of 5 pi over 6. All right, so sine 5 pi over 6, that changes my angle. I'm now over here. Oh, that's still a 1/2. That's still a 1/2. And we just knew on the other one that the inverse sine of 1/2, right, because we're in quadrant 1, have to be in quadrant 1, is pi over 6. So here is what I need you guys to understand. The reason, like this is nice, right? It looks like the signs just cancel each other out. Why didn't it work the same way over here? Well, what I need you to understand is this piece, right? This 5 pi over 6 was not in the sine inverse's domain. All right, so I can't let you guys get in the habit of just saying, well, sine and inverse sine cancel each other out. It doesn't work like that. You got to work through the problem. Okay? Okay. Let's do a couple more of these, and then we will be on our way, and I'll probably do a few more with you guys in class tomorrow to kind of clean things up a bit. Alright, so start with O, cosine of negative 2 pi over 3. Let's think about this. Negative 2 pi over 3 would be down here, and not the best angle, down here. And we know that the cosine of cosine of negative 2 pi over 3 should be negative 1/2. So cosine inverse of negative half. Now we think the same thing. Well, I need to know where my x value is negative 1/2. But again, it's inverse cosine, so it can only be in quadrants 1 or 2. Well, that means I'm here, up in quadrant 2, and I know that that is 2 pi over 3. 2 pi over 3. How about this next one? Cosine of negative pi over 6 first. So inverse cosine of cosine negative pi over 6. Okay, negative pi over 6, if we sketch it, negative pi over 6 is right here. And we know that the x value of that would be, what? Root 3 over 2. Now, we have to draw a new picture. Why? This was not in this was not in quadrants 1 or 2 where we know cosine inverse has to be. Alright, so I need to re-evaluate this and think, well, I want the inverse cosine of positive root 3 over 2. So now, that's up here. I hope that makes sense why I had to switch. Inverse cosine has to be in quadrants 1 or 2. It cannot be in quadrant 4. So I have to redraw the picture and rethink this one through. Now, this just turns in to pi over 6. And I'll box that. Alright. Okay, I'm going to skip ahead. We'll maybe do Q and R together in class. I want to get through S and T. Alright, so I have inverse sine of 2. Okay. So I know inverse sine has to be a y value. I know it has to be in quadrants 1 or 4. Where is my y value 2? On the unit circle. Oh, wait a minute. Unit circle has a radius of 1. Inverse sine, or actually, excuse me, the ratio or the y value can never be 2. Undefined. Hopefully that makes sense, right? I mean, we even knew when we were graphing, if we go back, right? A normal sine curve goes up to a max of 1 and down to negative 1. 2 is not inside that. So you cannot take the inverse sine of something outside of negative 1 and 1. Now this last one, a solve problem, this is good practice. We're going to be doing quite a bit more of this. And for this idea, well, the first thing we have to do is we have to we're trying to peel back all the layers to solve for x, right? So the first thing we'd have to see is, well, I have 3 sine inverse x. I'm going to first need to divide by 3. So now I have inverse sine of x equals pi over 3. So that's a good start. What I want you to, again, think about, though, guys, is what we wrote up at the top of the first page. These two things go hand in hand with each other. If you have a ratio, well, you can take the inverse sine to get the angle. If you have the angle, well, you can take the sine of it to get the ratio. So I'm going to completely rewrite this. This is written backwards to me. I'm going to change. And I'm actually going to write it that sine of my angle is equal to the ratio. Okay, again, this was taking the inverse sine of an unknown ratio to get the angle. But now I can take the sine of the angle to get the ratio. And now I just think, well, sine of pi over 3 is up here, pi over 3, and I want the y value, so x is equal to root 3 over 2. Okay, so that was long. I hope that this stuff is making sense. I hope you guys are seeing that you need to have really good knowledge of your unit circle in order to complete these problems. Obviously, we will continue working. Obviously, I am here to answer questions. I hope you have a great day, and I will see you in class to practice tomorrow.